Welcome everybody to today's webinar on the HP 20SA series. We are excited to have you here to explore the advanced capabilities and applications of HP 20SA series, a recent launch from Epever in the inverter charger categories. And I will refer to 20SA for being short in this webinar about this product. And the 20SA is designed for 3.5 to 65 kilowatt hybrid solar system, making it suitable for both residential and commercial energy needs. Here's a quick overview of what we will be covering. An introduction. We'll start with a brief introduction to the 20SA series. Then we'll get into the specifics of its features and specifications. We'll discuss the appearance, the design. We'll look at how it's built and how to connect to it. And we'll explore the various working modes available. Working modes are an interesting topic. We will cover that. And we'll highlight the key features that make this series stand out. And finally, we'll open, as Sabrina mentioned, the floor for Q&A session to address any questions you might have. So why we needed the HP 20SA series? So the development of 20SA series was driven by a combination of market demand, customer feedback, and advancements in technology. So the energy landscape, as you are aware, is evolving quite rapidly, and there is an increasing need for more efficient, more reliable, versatile power management systems. And our customers have been asking for features that improves the performance, improves the scalability of the existing products that we have, and improves the ease of the use. And in response, Epever has designed the 20SA series. So let's take a look at this table, which outlines the main differences between the 20SA and the UP series or the Preceding series. You'll notice that the 20SA has the parallel output connection, which the UP series does not. And this is important for scaling up the power systems. With the ability to connect to up to 12 units in parallel, we can significantly increase the system's performance and system's output. And this practically is important for large scale installations where a single unit's capacity might be insufficient. Then we have the dual PV inputs. This means that the 20SA can handle power from two separate solar arrays simultaneously. And this feature allows for better energy management and maximizing the capture of solar energy throughout the day. For instance, you can have one array facing east, another array facing west, and ensuring that you get the most out of available sunlight for, from morning to the evening. Then we have the power limit conditions for nominal PV utilization. We see a significant improvement here. So the 20SA series can utilize the nominal power starting with the voltages like 200 volt, and this is significantly lower compared to the UP series, which required higher voltage needs. So this lower voltage requirement makes the system more versatile and easier to set up in different PV configurations, ensuring you get the optimal performance more easily. Then we have the MPPT voltage range. So with 20SA, this range is expanded. And a wide MPPT range allows the inverter to efficiently track and utilize the power from the solar panels under various conditions. It could be in a less than ideal sunlight or in a cloudy condition. So this comes quite handy. So the maximum continuous output power is also improved. The 20SA can handle up to 6,000 in no battery mode and 8,500 in battery mode, which of course is significantly higher in comparison with preceding series. It comes with built-in Bluetooth. This means that you can easily make a wireless communication, so to control and making it convenient for you to monitor and manage the system via a smartphone or any Bluetooth enabled devices. Then we have the non-inverter generator support, number 7. So this non-inverter generator is a traditional type of generator that provides electricity. It's often simpler, cheaper than the inverter generators, but it can handle, the power. The downside is that it has sometimes fluctuations and in some sort of inefficiencies in the power that it provides. So being able to support non-inverter generator makes this product suitable for many types of existing generators at your project. SOC management mode. So the state of the charge management is another upgrade. The 20SA can manage battery charge and discharge based on the SOC value that it learns over the time and via the BMS. And this ensures the battery operates efficiently, and it prolongs its life and maintaining maintenance periods um, related to the batteries. So the charging mode, when it comes to charge modes, the 20SA provides more options and improved charging logic. It supports various modes like solar, solar priority, solar and utility priority. And this flexibility allows you to optimize charging strategies based on available power sources, ensuring, the efficient energy usage in your projects. And finally, we have the discharge mode options as well. And the 20SA features improved discharging logic, checking the input from PV, batteries, and grid, and deciding which source to use and which source to implement, which makes it also easy to adapt this product to specific requirements in different conditions. Now let's dive into an introduction about this product. So here we had the 20SA, which first off integrates multiple power sources. That means it can handle utility power, generators, solar power, and even battery backup all in one unit. This makes it incredibly versatile and perfect for a range of applications, whether you are using it in a residential setting or in a commercial one. And the power quality is one of the standout features of the 20SA. It provides high quality, stable, and reliable power, and this is thanks to its design and advanced technology. And it delivers consistent power. And there are slides dedicated to how good this power is and why this is happening with 20SA series. Another key technical feature of the 20SA series is the parallel operation. So the 20SA supports up to 12 units in parallel. This is particularly useful in large installations, as mentioned, like commercial solar farms or industrial applications. And as you can see in here, there are some challenges related to parallel communications in inverter world. So in the top graph on the right, we have two sine waves representing the output voltages of two inverters, for instance. For successful parallel operation, these waves must be synchronized both in frequency and phase, and any discrepancy can lead to circulating currents, causing inefficiencies and potential damages. So this requires an accurate, fast digital signal processing to ensure these waves stay in synchronization together, and the power output is smooth and effective without any losses. Load sharing is another challenge in a parallel world. So looking at the middle graph, this illustrates the concept of load sharing between the two inverters. Imagine the load of one inverter increase and the load of the other inverter is decreasing. So proper load sharing ensures that no single inverter is overloaded while others are underutilized. So 20SA series intelligent load sharing algorithm distributes the load evenly across all connected inverters as depicted, and this is again thanks to the digital DSP functioning of the 20SA. We also need to regulate the voltage because sometimes we have some irregularities in the voltages of the loads. Sometimes not all the inverters are working under the same load conditions, same load voltages. So this is also important that whatever fluctuation is there in the PV input or the loads inputs, the output of the parallel units together must be consistent and close to the nominal AC voltage that there is in the output. So at the heart of this inverter, there is this DSP, and it helps by sampling required parameters and provide this parallel functionality for the inverter. Also, the 20SA series features customizable settings for different working conditions. We will learn, for instance, why modes are important and what the application is. And there's also advanced protection mechanisms, which we will also learn during this webinar what they are. So let's break down the naming convention to understand what each part of the model signifies. So HP at the beginning stands for high power, indicating that this inverter charger is designed for high power applications. Next, we have the 35. This represents the inverter's rated power in hundreds of watts. So 35 here means 3,500 watts. Then uh, following that, the digit 4 indicates the nominal battery voltage, and 4 means this device operates at 48 volts. Then we have the digit 2, which denotes the inverter output voltage. Here 2 means the 220, 230. Then we have the letters AH, which stand for asynchronous high frequency transformer, and we will learn what that means in this webinar. So 0.6 refers to the PV maximum charging current multiplied by 10. So 0.6 means a charging current of 60 amps. Then we have the 50, which indicates the PV maximum per circuit multiplied by 10. This means that this unit can handle up to 500 volts of DC from the PV input. P20 is actually referring to the ingress protection, and finally SA is related to the specific region that is this product is designed for and suitable for, and SA in this case is the South Africa. So let's continue with looking at the exteriors of this product. First, there is this large LCD screen with real-time data display, and as you can see from the front panel of the 20SA series, there is a big LCD screen that provides real-time data. This screen is important for monitoring system performance and status at a glance. So whether it's power output, battery status, or the error messages, having this information readily available helps users to manage their systems more effectively. Next, we also have the LED indicators, and these LEDs are useful for quickly understanding the operation status of the device. For instance, they show the power status, the charging status, and any fault conditions, which is very good for troubleshooting the system in case of errors. So again, the 20SA series also supports two PV inputs, which you can see in the diagram, and the dual input capability, as mentioned, significantly enhances the utilization of the solar energy. So there is also built-in BMS Link module, and this module is compatible with 27 brands of lithium batteries today, so that you can connect to different parts. And if there is a battery that is not in the protocols yet, we are more than happy to help update those protocols and bring that type of battery into our portfolio. For the communication, the 20SA series features isolated RS485 port, and this port supports communication via Bluetooth, 4G, Wi-Fi, or LAN, depending on which accessory you use, and basically you can use it for local monitoring and remote monitoring as well. There is also the terminal or the relay terminal for remote controlling system, and this internal terminal allows for remote operation of all types of generators. So adding flexibility in cost management and when to turn the generator on and when to save the fuel of the generator. In terms of cooling, also 20SA employs a forced air cooling. And this system helps to maintain optimal operating temperatures. It also extends the lifespan of the inverter and charger. And finally, it must be noted that the 20SA series is designed for 1.45 times, almost 1.5 times rated power overload ability. And this means that it can handle up to 1.5 times its rated power during the bypass operation, which is essential for maintaining performance and reliability during, for example, unexpected load increases. So in this block diagram, we will also visualize the operational framework of 20SA. We will start by understanding how a system, gets the solar energy, manages the battery charging, and etc. So as you can see in this diagram, we start getting inputs from two PV strings labeled PV1 and PV2. These connect to the maximum power point tracking inputs, which ensure optimal power extraction from the PV panels. And the DC-DC conversion here, the energy coming is first processed by the DC to DC converters here, and these units convert the variable DC voltage from the PV panels to stable high DC voltage. This is called the high DC bus here. And the high voltage is important because it minimizes current flow. It reduces the power losses because the power losses are proportional to the square of the current. And with the higher DC voltages, you have less losses and you have better conversion efficiencies. Now let's see how the batteries charge. So the high DC voltage generated from the PV panels is directed towards this edge bridge. And this edge bridge plays an important role. It converts the high DC voltage to the low DC voltage needed for the battery to be charged. And this bridge here is consisted of switches which are arranged in basically edge configuration. This means that it allows for bi-directional current flow, which is essential for both charging and discharging the batteries. So when the battery needs to provide energy to the output, the process is actually reversed. So we need this bi-directional. The energy stored in the battery at the low DC voltage is converted back to high DC voltage. So we have high DC voltages here in the high bus here. And if we want to generate energy from this high voltage, the energy needs to be converted into AC again, and this is happening in this edge bridge here and the PFC filter or power factor correction here. So the edge bridge converts the DC to AC by switching the current flow and generating AC waveform, and the PFC filter smoothens out this waveform, ensuring it's clean and stable for the AC load. And this is essential for maintaining power quality and protecting the connected devices to it. So the system also supports charging the battery from the utility grid, and the utility power is converted again to the high voltage and again back to low voltage DC volt. And there is also the no battery mode. And in no battery mode, the system can still operate and provide power directly from PV or from the utility grid. And the conversions happens as we have just already explained. So this is basically about the working principles of such a hybrid unit, and this one provides us an overview of the internal PCB. We start with the fans. This is a forced cooling system. We have fans over here, and it's important to dissipate the heat generated by internal components, and effective cooling is actually essential to prevent thermal stress or sensitive electronics. We will either lose the lifespan of the instrument if it's really working in really hot environment, or the power will be degraded. That's what we don't want. That's why we have fans here. Then we have the utility charging plus inverter plus auxiliary power board. And this board, you can see here, is also the heart of the inverter charger, and it handles the main functions, integrating utility charging, inverter operations, and auxiliary power management. So this significant inductor here um, is our PV inductor, an essential part of DC to DC conversion, as you have seen in previous slide, and it plays an important role in MPPT, maximum power point tracking. And it helps to smoothen the current, and it reduces the ripples and also does the conversions. We have the MCU, and this houses the microcontroller unit, which is the home for ESD, which is essentially the brain of the system, and it executes all the control functions, managing operation, reading sample data from everything here, and controlling that. We also have the communication board for for parallel functioning, and this board facilitates the communication between multiple units in case of parallel usage, and is in the side of the inverter, as you can see. So then we have on the right side the PV input terminals. Of course, this connects the solar panels to systems and handles the high voltage, provides the protections, etc. We have the battery input terminal. This ensures a stable and secure connection with the energy storage systems, also with protections. We have the PV charging plus auxiliary power boards, input anti-reverse, anti-surge current board for battery input. And this is also important because this helps to protect the batteries and the entire system from the anomalies that might be present in our installations. So we have AC input and output interface board. This manages the AC power input from the utility and grid and the AC output from the unit to the load. It includes filtering, protection circuits, and it ensures to deliver clean, stable AC power output, with preventing any disturbances to the connected devices. We have then the LCD plus BMS link, the capability to connect and talk to the lithium batteries, which is becoming, the default here in this industry. And as a final note here, every PCB in our system, it has 100% of coating to protect against electrostatic discharge, humidity, corrosion, and this ensures durability and reliability even in some harsh environments. So with that, we dive into the essential connections for the 20SA and how do we connect to the system, how we do the different steps. Of course, first things first, we start with grounding. We need to make sure the cabinet and both the AC input and the output PE terminals are reliably grounded. And this step is really important for the safety and preventing the system from the hazards and other problems. After we did the grounding, we go for the batteries. We need to protect the batteries with a fuse, and this battery is almost 1.4, 1.5 times the system's rated current, and higher than that means in abnormalities. Of course, the lithium batteries have their own protections. They will cut off, but if the lithium is not used, then we'll need to implement a fuse, external fuse for that. Then we need to connect the AC load, ensure the continuous output power and the transient surge power of the load are below the specified limits to prevent any damages to the inverters. It is also recommended to have your protections in the load side to protect both the loads and the inverter from anomalies. PV connection, of course, if you are using that in areas with high lightning frequencies, then surge suppressors are essential within this connection here from the PV to the system. Then you can connect the utility. Protections might be required there as well, depending on the grid power quality, to prevent damages to the inverter and connect the systems. And finally, connect any accessories based on your requirements, if it's a local monitoring or if it's a remote cloud monitoring system. And after that, we have working modes. So the flexibility offered by 20SA ensures that the system can adapt to different energy sources and consumption patterns, which is valuable in diverse locations and application scenarios. So having said that, just imagine you have a remote rural area with limited or no grid access. So the grid is not there. The primary energy source is solar power there. So you will go for solar only mode, because in solar only mode, the system relies entirely on solar energy for charging the batteries, and this ensures a sustainable and economical solution for powering homes or community centers in such remote areas. But now consider an urban setting in Europe where the grid is reliable, but electricity costs are quite high. So we will go for solar priority. And what this means is that the solar priority mode minimizes reliance on the grid by prioritizing the solar energy for charging the batteries. And this significantly reduces the electricity bills by maximizing the use of solar power instead of using the grid power. In a different scenario, think of regions in South Africa which are prone to, or South Asia even, which are prone to frequent power outages, making uninterruptible power supply, important. Here you will go for solar plus utility default, and this means that this mode combines solar and the grid power to ensure the battery is always adequately charged. And finally, in industrial applications where uninterruptible power is important, such as manufacturing plants or medical applications, you will go for utility priority. This means that you need to ensure that the grid power is always available for charging the batteries, and solar power is used as a backup to charge the batteries, and this maintains operational continuity, avoiding any disruptions in critical processes. So this is about a charging mode. We also have discharge modes, or the output modes, based on what we actually need. So it is looking into the available energy from the grid, from the solar panels, and from the batteries, and it decides which source of energy to use. Imagine you're using the system during the night, and of course, during the night, solar panels is not available. Utility might be available, but that's the reason you have batteries, and you might want batteries, stored energy in the batteries to be consumed first, and then utility, and tomorrow morning the power from PV panels will be available. So this is in general how output modes help to configure our consumption style here. In this slide, we see some technical features of HPHP series, focusing on its advanced capabilities. Of course, pure sine wave output. The inverter provides a pure sine wave output. The quality within a full load is around 93% and a maximum efficiency of 94.9. Then we have the advanced MPPT technology. We have already discussed this. We have the three-stage charging method. It's famous one from Epever and has been already covered in previous webinars, so you can refer to it if you want. It has a wide AC input range, and it accepts AC from 90 volt to 220, and the frequency range of 45 Hz to 65 Hz. And this flexibility ensures compatibility with diverse grid conditions globally, making it ideal for regions with unstable power supply, or some other types of generators. We have the advanced power factor connection technology, important for the power quality and of course the bills that we receive. We have stable lithium battery self-activation, smart SoC learning, so the system learns the state of the charge of the battery from the BMS link and it adapts its charging profile to what it has already learned from that BMS connection. We can adjust the charging and discharging current, which is also an interesting feature to make sure that you can configure the 20SA to different types of the batteries. Maximum utility charging current is adjustable, and it also has strong impact resistance, which we will cover in the coming slides together, and it comes with lower power consumption. Basically, it makes sure that the system can be used in standby mode for a longer period. So we also have comprehensive protective functions, the self-recovery function. The system can self-recover 3 times after an overload, and this feature is important to minimize the downtime because it automatically restores the operation without any manual intervention here. And then we have the PV input protections, the utility input protections, the battery protections, the covering the reverse polarity, over voltage, over discharge, and high or low temperatures regarding the batteries. Then we have the load output protections, short circuit, overload protection, and other protections such as overheat protection using the air forced cooling system or the power degradation that happens. And another interesting feature is the historical data availability with the system. System stores some historical data, and in case of needs, it can be used for understanding what happened to the system or what was the problem, and it eases the troubleshooting process for the inverter. And it also has a dual protection system, both with software and hardware. So in cases of the software malfunctioning, hardware protections still are there. They safeguard the system, ensuring continuous protection. So the multi-unit connection. We have already covered the parallel connection. We can review the differences between the single phase and the three-phase system. In a single phase system, multiple inverters are connected in parallel to common bus, and each inverter has its own PV input, battery connections, and the load output. And it is important that all inverters are synchronized to the same phase to prevent phase mismatches, because otherwise you will have insufficiencies and there will be potential failures in the system. And this setup is good for residential or small commercial applications. You can put 2 to 3 or 5, and you can go for the powers like 10 kilowatt, 15 kilowatt, something like that. The grounding is very important. We need to ensure that all equipment is grounded according to the local electrical codes in your country. We need to carefully manage wiring to provide cross connections and phase imbalances. Normally we use color-coded wires to maintain clear documentation of the system. Of course, synchronization is also important, being taken care of the DSPs of the 2NSA. And a three-phase system, this one is suitable for, of course, larger installations, because the three-phase system inverters are divided into 3 groups, and basically they serve different phases, A, B, and C. And this configuration distributes the load evenly across 3 phases, ensuring balanced power delivery and maximum overall efficiency of the system. So we need to monitor and correct phase imbalances to avoid insufficiencies and potential system failures. Of course, the automatic phase balancing technology is embedded, but it's also important that we do not intentionally overload one phase in comparison with the others. We need to clearly label all phases and ensure correct connections to prevent power quality issues. We need to do the load sharing properly, implementing robust load sharing protocols to ensure even distribution of the power across all the phases. And yeah, basically there are some practical aspects of using the systems in parallel in single phase mode or three-phase mode. This slide tries to depict the fact that 20SA is compatible with different sorts of batteries. So we have many kinds of batteries, starting from lead acid batteries. They have been around for quite some time and continue being widely used across the world. They are reliable, they're cost effective. So the AGMs are known for their lower maintenance, higher performance, especially in cold temperatures. The gel batteries are excellent for deep cycle applications. The flooded ones, they're good, but they require maintenance. And you just go for it if the regular maintenance is available for you. Lithium batteries becoming standard in the industry here. Either that's LFP, LCNM. They're more reliable. They're suitable for deep cycle. They don't have memories, so all suitable. And 20SA provides some sort of means to get into contact and utilize all those different types of the batteries with many protections in place: automatic temperature compensation, self-activation, low temperature protection, adjustable charging and discharging current, and wide operating temperature ranges. And here we see the power output quality. So here this graph shows a pure sine wave output of the inverter. This is important. Pure sine wave is very important. You have less power and efficiencies. You can connect it confidently to specific sensitive electronics. And in this yellow line, you can see the voltage output, and this magenta line shows the current. So both waves are synced, indicating the efficient operation in load varying conditions. So basically here in this experiment, the load is varying quite drastically, but the inverter is trying to keep its output in the sine wave format, both in terms of voltage and current. And the utility power factor on the right side, you can see here, is a measure of how effectively the electrical power is being used. So a power factor of 0.99, as shown in this image, indicates that the inverter is almost perfectly efficient in using the power it draws from the utility. And this high efficiency is good for reducing energy losses and ensuring that you are getting the most out of your power system. And it also has economic benefits. You have less bills. You don't waste the power because of the reactive conversion here. And this together showcases a reliable, high quality power from the 20SA. And of course, the multi-state charging, this has been discussed multiple times in our previous webinars. So the charging profile is the same. We have bulk, boost, and float, and equalized phases. This ensures that the batteries are being charged and discharged in a healthy manner, and this ensures a prolonged life for the batteries, which is economically very important because batteries might be very expensive. And finally here, we will explore the critical features of strong impact resistance in inverters. So load variability is the main challenge here. Inverter must handle sudden changes in power demands without compromising the performance. And surge handling is also another factor. Inverter should manage the surge currents higher than operating currents without failure. And it must stay reliable within different conditions. So the display here shows three waveforms representing different inverter parameters. The yellow waveform is the internal current, the green one is the inverter output voltage, and the blue one is the inverter output current. And altogether, this shows that although the load is varying here, but the inverter is trying to remain sinusoidal and remain consistent in terms of power. And this is good for protection against transients, to extend the lifespan, because effective stress management extends the inverter's lifespan. This is good for performance because a stable voltage and current ensure connected devices operate without interruptions or without damages. So in this graph, we try to demonstrate the importance of being resistant to load variations and providing stable power output. Of course, there are a diverse set of accessories where you can use to either locally monitor the system or get the data on a remote location, whether you have your data server, whether you are using our cloud system, whether you want to implement something specific customized to your needs. You can go for one of the accessories that is mentioned here and is also available on the product manual on our website, and match it with your 20SA to make sure that you are getting the most out of your system. And finally, we have the key specifications of the 20SA series, where you can refer, learn more about a product, and this will help you to uh, basically make wise choices based on what you need. So with that, I would like you to thank you for your attention, and we are opening the floor for Q&A